Hey guys, in this video we're doing lesson 7.7, which is on composite figures. So this lesson is going to require you to really think about the shape, think about what's included, what's not included. So it may seem a little harder. The volume ones tend to be easier than the surface area. So number one, we're finding the volume. And we have two shapes. We have a trapezoidal prism and a rectangular prism. So let's do the volume of the trapezoidal prism. So volume is the area of the base, which in this case is the trapezoid. Make this a little smaller. So this is my base. And then we will need the height of the prism. Now remember, the height is the length from base to base, which is 13. So to find the area of a trapezoid, it's half times the height of the trapezoid. So this height, let's see, I know that this part is 8 because it tells me back there. And so that leaves 14 because the whole thing is 22 centimeters from bottom to top. So 8 and 14 give me that 22. And then, in parentheses, I add these two bases. So 17 plus 6. And this is going to give me 161. So the volume is the area of the base, 161, times the height. Remember, the height of a prism is not from bottom to top. It's from base to base. So 13. 161 times 13 is 2,093. Then I have the volume of the rectangular prism, which is length times width times height. Or you could still use the other formula, area of the base times height. So it's basically the same thing. But for this one, we have 17 times 13 times 8, which is 1,768. So my total volume we add the two, 2093 plus 1768, which is 3,861 centimeters cubed. Well, that one wasn't too bad. All right. Number 2, the cylinder below contains two congruent hollow cones. So we have a cylinder and we've cut cones out of them. All right. The cylinder's height is 20. And the diameter is 14, but remember we always use radius, so the radius is 7. Now if the height of the entire cylinder is 20, what is the height of one of the cones? 10. So we have the volume of a cylinder And because we're cutting out the cones, that means we're subtracting the cones. So we need to find the volume. I'm just going to put V with CYL, volume of the cylinder. That's pi r squared h, which is pi times 7 squared times 20. This is the cylinder. The entire cylinder is 20 inches. And this gives us 3,078.76. Okay. Then we have the volume of the cones. And so a volume of a cone is 1/3 pi r squared h, but we have 2 of them. So we have 2 times 1/3 pi r squared h, because there's 2 cones. You could just do the 1 cone and get an answer and then multiply by 2 at the end. It doesn't really matter. Pi r squared. Now remember, the height of each cone is just 10. And if you multiply this, you get 1,026.25. So the total volume, we have to subtract because we have this cylinder and we're taking out the cones. And we get 2,052.51 inches cubed. All right, next one. So this one looks like we have one big cone and we've chopped off or taken off a smaller cone. So we're going to need to find the volume of the large cone first, and then the volume of the smaller cone that was cut off, and subtract. So the large cone has a height of what? Well, 15 and 10 make 25. The radius of the larger cone is 9, because the diameter, it tells me at the bottom, is 18. So the volume, I'm going to put LC for large cone. That's 1/3 pi r squared h. So fill in. We get 2,120.58. All right. Then the volume of the small cone is 1/3 pi r squared h. Now my radius is 4, because it tells me here at the top that diameter is 8. So my radius is 4, and the height of just the small one is 10. So if we multiply that out, we get 167.55. So the total volume is, we subtract, to get 1,953.03 inches cubed. All right, number 4, find the surface area, not including the bottom. So basically we have some kind of tube, some solid tube that we've cut, and we're going to paint every part but the part where it's cut. Now, if that wasn't the case, then we would have half, because this is kind of half of a cylinder, right? We would have half of it, but we would also have had to have added in, there would have been a rectangle here at the bottom. We would have had to add that, but the question says not including the bottom, so we don't have to worry about that. So really, this is only half of the surface area. So surface area is half, and then we've got 2 pi r squared plus 2 pi r h. Or you may be used to doing that flip-flopped. So we have 1/2 times the whole surface area. 2 pi, my radius is 3, plus 2 pi 3. My height is 25. Now, the reason that I couldn't just do, the reason I have these extra parentheses is because if you just did 1/2 times, it would not send the 1/2 to this part. So you've got to be careful. You could have just found the whole surface area and then divided by 2 at the end. And when you type all of that in, you get 263.9 centimeters squared. All right, number 5, find the surface area. Now this is only the area on the outside. So when I have a cylinder and a cone stacked, we don't include this part at all. So the cylinder, if we were to break it apart with this, or with the cone, I'm sorry, that would just be the lateral area, because we don't include the base. But on the cylinder side, we still want to include the bottom. So it's basically the lateral area plus 1 base. If we did the entire surface area, it would include this top. But we want 1 base. So we could do the whole surface area minus 1 of the bases, or we could do the lateral area plus 1 of the bases. It's equivalent either way. So for the cone, it's, let's see, the lateral area is pi RL, slant height. So pi, the radius is 17, and the slant height is 20. Which is 1,068.14. So the lateral area is 2 pi RH, but if we're adding 1 of the bases, that's just pi r squared, 1 of the circles. We don't include the ones that are being covered up by the cone. So 2 pi 17, my height is 12. plus pi r squared. And this is 2,189.69. So this is kind of why I said they can be kind of confusing, because you really have to think about, okay, do I include those circles? Do I not include them? How many do I take off? It can be very confusing. So you have to really stick and wrap your mind around it. So the total surface area, we add the two together, and we get 3,257.83 meters squared. Number 6, a cylinder with a 2 centimeter diameter. Okay, so we have a centimeter, or a cylinder. The diameter is 2, so the radius is 1. That's drilled through the triangular prism. We want to know the volume. So we have a prism, and we're subtracting out the cylinder. All right. Excuse me. All right, so let's look at the volume of the prism first. That's area of the base times the height. So my base is a right triangle. And we already have we don't have to do Pythagorean theorem or anything. So the area of the base, it's half. Now remember, you're on a triangle, your base and height are what create the 90-degree angle. So 5 times 5. That's 12.5. So 12.5 times the height of the prism, which is 14. And this is 175. Then the volume of the cylinder, that's pi r squared h. So pi times 1 squared times 14. Which is 43.98. Now my total volume, we have the prism, and we are subtracting the cylinder because it's being cut out. So 131.02 centimeters cubed. All right, number 7. The Henleys have a silo on their farm to store grain. Assuming the entire space is used, what is the maximum amount of grain the silo can hold? So if we're putting grain inside of it, that's going to be volume. So we have a cylinder and a hemisphere. So why don't you pause the video and see if you can find the total volume. All right, so if you do the volume of the hemisphere, then you get 2,787.64. It's 2/3 pi r cubed. And then the volume of the cylinder is 12,924.51. And so the total volume is 15,712.15 feet cubed. All right. Number 8 is another tricky one with surface area. So basically we have two cylinders, which doesn't seem so bad, but it's the part that you got to take off that makes it harder. So in the smaller cylinder, just like before, we have like the lateral area, so we have this part, and we have the top, but we need to subtract off one of the bases, or we do the lateral area, so we can do the lateral area, which is this, plus one of the bases. So if we do lateral area plus one base. Now the larger cylinder, we really need to do the entire surface area, but we are subtracting, let's use my eraser here, we're subtracting this part. So we're subtracting the base of the smaller cylinder. So we would do the whole surface area minus the base of smaller cylinder. So doesn't it make sense if we just take off this part and this part? They kind of just cancel each other out, right? Instead of adding here and subtracting there, we're adding and subtracting the same thing. So it makes sense just to do the lateral area and then the surface area. So why don't you see if you can do that? Find the lateral area of the smaller cylinder and the total surface area of the larger cylinder. So this is pi, or 2 pi, sorry. 2 pi RH. Is that right? Second guessing myself here. Yes, 2 pi RH. So 2 pi. All right, here's another thing. The radius. All right, we have an entire 38 for this spot right here. And then this is 13 and this is 13. So if we do 38 minus 13, we get 12 for the diameter. So the radius is 6. And then the height, we know this part right here is 14. So that leaves 9 for the rest of the height. And we get 339.29. Now the surface area is 2 pi RH plus 2 pi R squared. So 2 pi, the radius of this one is 19, and the height is 14. And we get 3,939.56. And so the total surface area, if we add those together, is 4,278.85. So I know those surface area ones can be tricky, really, really tricky. So you have to be very careful and really think about it. If you have